Let's look at final exam question number 12 in Geometry Demystified, 2nd edition. Please refer to page 343, where we are told that we have a certain line called L and a certain point called R in Euclidean 3-space. Well, as things turn out, whenever you have a line and a point not on that line, assuming that this is a straight line, the line and the point together define a geometric plane. In this case, of course, that plane is the plane of the beige board on which I have drawn this crude rendition of the situation. The question asks us, how many lines can we find through that point R that run parallel to L? Well, the answer is one and only one. Exactly one. It would have to lie in the same plane as the plane defined by point R and line L, and in addition, it would have to never intersect line L. It has to fulfill both of those requirements in order to be parallel. So, the correct answer in this situation is B. One line through R can exist parallel to line L. Now, we can have an infinite number of lines that pass through point R but do not intersect point L if we are willing to let these lines venture outside of the plane defined by point R and line L. But any of those lines, any lines that do not lie in this plane and pass through point R, result in a pair of skew lines. Line L and this line would then be considered skew lines. Not parallel, but they would not all lie in a single plane, so we would need 3 dimensions to define skew lines. But again, in this situation, with this question, choice B is the answer.